Nelson Mandela University under the theme Advancing Science Tourism. So the whole morning I've been standing in a patio with rain, but now we are officially with future scientists. How lovely is that? And we're going to speak to them earlier on and also find out from them exactly what are they doing at the various exhibitions at the National Science Week. And joining me is Glenn, who's going to take us through exactly what these various experiments are. You guys are from the Department of Electrical Chemistry at NMU. So take us briefly. I won't talk anymore. You will take us briefly through exactly what you're doing here and how fun science can be for young people.
All right, I'm Dr. Gletwin Rubich from the Nelson Mandela University Chemistry Department. We're going to start off with a couple of reactions we're going to show to you guys. But just a little bit about what is chemistry. It's the interaction of different elements in the periodic table. If you look in the background, there's a periodic table. That picture at the wall at the back with the different elements interacting together, and then they form various products. So that's basically what chemistry is, interactions between elements. Let's go to our first reaction over here. Seethle is one of our students in polymer technology. He's putting in some latex into there. Right, liquid latex, it's stabilized with ammonia. And we have over here, in this bottle, he's got citric acid. He's going to add some citric acid to it. And let's see what happens there. Go ahead, Seethle. Okay, should do. He now stirs it up. The ammonia is alkaline or basic, and it reacts with the citric acid. And if you look closely, we can see that it's starting to thicken.
So this is a combination of my word. This is a combination of what and what is actually produced in the end.
Right, that's latex, the same as you would find in a tree, in a rubber tree. So we've got liquid latex over there. He's reacting that with citric acid. It neutralizes the ammonia, and then it stabilizes the polymer, forms larger chains of polymer. They come together like that, and he's going to make this into the equivalent of a bouncy ball. A bouncing ball that can actually bounce. And that's rubber. It's gone from the liquid state to more of a solid state rubber, and this would now be able to bounce nicely.
Okay, this is like an interesting one. The next one here, I see planks, and I see, you actually explained to me what's going on this one.
All right, let me explain what we're doing here. So what Mzikisi is over here, he's doing this next experiment for us. He's an analytical chemistry student. He's got some methanol.
Wait, just so nothing's going to explode here, right? Okay.
This one, that might come later. He's ignited a little bit of methanol, and it's got some boric acid in, which forms that green flame which we're seeing now. If you guys can maybe just put on the tower. He puts on the tower, and we make it into a flame tornado, and the flame changes color by itself. So it's alcohol burning there, methanol reacting with oxygen, forming carbon dioxide, water, and of course heat. And then we've got boron in the form of boric acid causing those green flashes in the flame, and then also sodium causing the sort of a yellowish orange color.
I see Simpu is very excited. Do you find that when you practical science, students enjoy it more?
Sorry,
I'm saying that I see Simpu is very excited about the fire and everything else. Do you find that when you practicalize science, students actually enjoy it more?
Yes, they absolutely love it. It's always nice for them to see something exciting, something stimulating, and that's what we do quite a lot of at our department. And this will normally intrigue them. They'll sort of ask questions. Why does it turn around? Like, what is causing it? And then if they question what they're seeing, they will then inspire their learning capabilities.
Okay, and I see that the last one that we have right now, early on there was an explosion, so I'm going to step aside a bit and tell us briefly what this one's about.
Okay, what we have here is an old coffee tin, something that is readily available. We're going to make use of some methanol. They're going to put some methanol into that tin. Methanol we saw burning early on as a fuel. What we try to simulate in this reaction is the equivalent of what's happening in your car engine. So in your car engine, you've got fuels being injected in, mixing with air, and then of course a spark comes along to perform the ignition. And then the explosion inside the car engine, or the power driven and the volume change, will actually turn the engine. And let's see if they can do a similar reaction here now. That's what drives. We would often ask people, how did you get here on this day? And it's normally the fuel in the car engine has now driven you, but through the mechanical device of the car engine. Let's go over to the experiment.
Okay, so as you watch the experiment, you'll get to see that obviously these are young students from Nelson Mandela University, from the Electrical Science Department. Whoa, okay. So you saw an explosion there. I couldn't even add, that gave me a fright. So you saw earlier on that, as the professor was saying, practical science is a way to make it enjoyable for young students. We saw how excited they were in their faces as they did the very experiments. So saying that perhaps making science finds through experiments like these is a key way to make science and maths grow in this Eastern Cape province. For now, it's back to you in studio.